In question 1, we have that the ratio of A to S to K is equal to 5 to 8, and the difference between 2 and 5 is equal to 3, and this is 3 parts of the ratio, which corresponds to 12 goals. Now 8 parts, which is K, corresponds to X goals. So X is equal to 8 times 12 over 3. Do this calculation, you'll come out with 32 goals. In question 2, I'll first need to add 2 extra columns, one for the midpoint of the number of minutes and one for the product of the frequency with that midpoint. So Fx is the label of that column. Now F obviously is the frequency. So let's find the midpoints. I've got 15, 45, 75, 105, and 135. Now let's multiply 5 by 15 is 75. And let's repeat for the rest of the rows. I get 270, 600, 945, and 270. Now, the estimate for the total number of minutes is the sum of the column Fx, denoted as sigma Fx, and if you add those numbers, the answer will come out to be 2160, and this is our final answer. I'll start question 3 by calculating the 70% of the 60 notebooks. This gives me 42 notebooks. Now I'll multiply the 42 by 22, which is the unit price for each notebook. This gives me 924 dirhams. Next, I'll find the other 30% of 60 notebooks, which is equal to 18 notebooks. Now, each one of those 18 is being sold for 19, which comes out to be 342 dirhams. And now I have a total income of 924 plus 342. So let's write this down. Income equals 924 plus 342, which is equal to 1,266 dirhams. Now the profit is equal to the income minus the cost, which is given in the question. So it's 486 dirhams, which means that the percentage profit equals to the actual profit over the cost times 100. Put this on the calculator and you'll get an answer of 62.3, and this is my percentage profit. An easy way of doing question 4 is to find the vectors that connect the 3 vertices of the triangle, and these vectors are the following. Note that these vectors are parallel, and I'm going to use the blue one to find the x and y component of the vector. Now from -7 to 6, I've got a horizontal movement of 13, and from 2 to 12, I have a vertical movement of 10. So this vector is equal to the other two, and considering the y coordinates of the red vector, I can write down the following. -5 plus 10 equals to d. Solving for d will give me a value of 5. Next, moving on to the y coordinates of the purple vector, I can see that -3 plus 10 will give me e. Let's write this down. -3 plus 10 units up will give me E. Solving for E will give me 7. And finally, considering the x-coordinates of the purple vector will give me F plus 13 units to the right is equal to 9. Let's write this down. F plus 13 is equal to 9. Solving for F will give me a value of minus 4. In part B, I have to describe the enlargement that maps P onto Q. Obviously, it's an enlargement. I need to find the center and the scale factor. Now, the scale factor is easy. Take any side. For example, this one has a magnitude of 2. It's being mapped on this one with a magnitude of 6. Going from 2 to 6, a scale factor of 3. Now, to find the center, I'll need to join two corresponding points. For example, this one with this one, and another one, for example, this one with this one. Join them, and where these two meet will be the center. So doing so will give me the following. So the center of enlargement is 0, 2. So let's write this down. We've got an enlargement, center 0, 2, scale factor of 3. In the next part, I'll need to rotate shape P 90 degrees clockwise about the point 35. Let's start by locating point 35. Now, to do the rotation, you can use tracing paper and rotate the shape. If you don't have tracing paper, an easy way of doing the rotation is the following. Join any of the vertices of this shape to the center, for example, this one, and then rotate this line 90 degrees clockwise. This will give me the coordinates of my first point. Repeat with another point and rotate 90 degrees clockwise. And that's my second point. If you figure the shape out, you can draw it. Otherwise, repeat with a third point. For the fourth point, you can use an angled line like this. And again, rotate 90 degrees clockwise to mark the final point. Finally, join the points using your ruler. In question 5, to find the perimeter, first I'll need to find the length of CD, which is this one. Now, CD is the same as the line joining A and B, which I'm going to draw now. And to find AB, I'll use Pythagoras theorem. I've got the right angle triangle. So AB squared is equal to 7.2 squared plus 5.4 squared. This comes out to be 81. So AB is the square root of 81, which is 9. Therefore, CD, which is equal to AB, is also 9. So let's complete the diagram. That's 9 centimeters. And AD is 6 centimeters, same as BC. Therefore, to find the perimeter, I've got 6 plus 9 plus 6 plus 5.4 plus 7.2. Do this calculation and you will get 33.6 centimeters. In part A of question 6, the power of 3 outside the bracket is being applied to the 2, the c to the 4, and the d to the 7. So I have 2 to the power of 3 times c to the 4 to the power of 3 times d to the 7 to the power of 3. And this gives me 8 c to the power of 12 d to the power of 21. Now, any number to the power of 0 gives me 1. So 5y to the 0 is like saying 5 times 1, which is equal to 5. In part C, I need to factorize. The common factor is 4a squared b, and I have left in the bracket 4b squared plus 5a. In part D, I need to factorize. The two factors are x plus 11 and x minus 2. Solving this being equal to 0 will give me two x values, and these x values are minus 11 or 2. In question 7, I have three lines bounding this region. The vertical line has equation x equals 1, the horizontal one y equals minus 2, and the slant one passes through two very important points, 0, minus 4, and minus 2, 0. Now I can take any 2 points on this line. I've just decided to take the x and y intercepts. And now I'm going to use the following formula to find the gradient. So this formula with 0, 4 and minus 2, 0 will give me a gradient of 4 minus 0 over 0 minus minus 2, which is equal to 2. Now I know the y-intercept, so the equation of this line is y equals 2x plus 4. The shaded region is above the line y is equal to minus 2. Below the line y is equal to 2x plus 4. And to the left of line x equals 1. Therefore, the three inequalities are y less than or equal to 2x plus 4, x is less than or equal to 1, and y is bigger than or equal to minus 2. Now, if you use strict inequalities, that is, you don't include the or equal part, then you get the following. You still get the 4 points as long as you are consistent. That means you do the same thing in all three of them. So do not have some of them with the or equal and some of them without it. For part A, I will divide 300 by prime numbers. So let's start. 300 divided by 2 is 150, divided by 2 is 75, divided by 3, that's 25, divided by 5, you get 5, divided by another 5, you get 1. Therefore, 300 is 2 to the power of 2 times 3 to the power of 1 times 5 to the power of 2. For part B, 5a is equal 5 times all these factors. So times 2 times 2 times 2 times 3 times 3 times 5. Now I can write this as 2 to the power of 3 times 3 to the power of 2 times 5 to the power of 2. Let's repeat for 7b. This is 7 times all these numbers. So times 2 times 2 times 3, 3, 3, and 5. I can write this as 2 to the power of 2 times 3 to the power of 3 times 5 to the 1 times 7 to the power of 1. Now to find the lowest common multiple of these two numbers, I need all the prime factors to their highest powers. So I get 2 to the power of 3 times 3 to the power of 3 times 5 squared times 7 to the 1. Now you can write this as an ordinary number. This will come out to be 37,800. So any of those two is acceptable. For question 9, I will proceed with the process of elimination. Now I will keep the first equation the same, so I'll multiply by 1 and I'll multiply the second one by 3. This will give me 2x plus 9y equals 14.5, and then 21x plus 9y is equal to 24, and then I will subtract. 2x minus 21x is minus 19x. The 9y with the 9y will cancel out, and the right hand side will be minus 9.5. So x is minus 9.5 over minus 19, and this will give me 1 over 2. That's the value of x. Now to find the value of y, I will replace in any of the two equations. Let's go with the first one. So 2 times 1 over 2 plus 9y equals 14.5. So 1 plus 9y is 14.5. 9y is 13.5. Y is equal to 13.5 over 9. Put this on the calculator. It will come out to be 3 over 2. And this concludes question 9. For question 10, to find the interquartile range, I will need to subtract Q3 minus Q1. Now Q1 is a quarter of 15, which is 3.75. So I will take the fourth observation, and 1, 2, 3, 4, this is equal to 15. To find the upper quartile, I will do 3 quarters of 15, which is 11.25. Round this up, so Q3 is the 12th observation. We'll always take the next position. So the 12th observation is equal to 25. So for the interquartile range, I've got 25 minus 15, which gives me 10. Now, because this is a small data set, I can find interquartile range by inspection. Now, the middle value is 19. 19 splits the data set into two subsets, one from 7 to 18 and the other from 20 to 40. And the middle of the left part is 15, the middle of the right part is 25. All this by inspection, and then you proceed from here. For part A, to find the y dx, you multiply the coefficient with the power, so you get 12x, and then you reduce the power by 1, so you get x squared, plus repeat coefficient 1 and power 2, multiply them, you get 2x to the power of 1, and then minus 20, because the power here is 1, so it's like saying 20 times 1 is 20, x to the power of 0, and x to the 0 is just 1. In part B, we have the x coordinates of the points where the gradient is 4. So this is like saying dy dx is equal to 4. Therefore, I'm going to get the answer from above. 12x squared plus 2x minus 20 is equal to 4. Take everything to the left. 12x squared plus 2x minus 24 is equal to 0. Now I will divide by 2. So 6x squared plus x minus 12 is equal to 0. Let's factorize this. 3x minus 4 and 2x plus 3 equals 0. So the x values I will get are 4 over 3, or x equals minus 3 over 2, and these are the two answers. Note that instead of factorization, you can proceed with either using the quadratic formula or by completing the square. To find the median in part A, I will do 50 divided by 2. This gives me 25. So I'll go on the vertical axis, find 25, and find the corresponding x value. As you can see, the value for the median is 28 centimeters. Note that the mark scheme accepts values between 27.5 up to 28.5. For part B, to find the frequency for the class interval 30 to 40, I will find the cumulative frequency that corresponds to 40 centimeters. Then I'll find the cumulative frequency for 30 centimeters, and then I will subtract the two. So I will do something similar to what I did before, but this time I'll start from the x-axis and find the corresponding values from the vertical axis. As you can see from the graph, the two values on the vertical axis I get are 44 and 30. So to find the frequency for this class, I'll just do 44 minus 30, which will give me 14 plants. For part C, I'll do something similar to part B. I'll go on the x-axis, find 35 centimeters, find the cumulative frequency for this, but what I'm going to find is the number of plants that are less than 35 centimeters, and if I want the number of plants that are more than 35 centimeters, I'm going to do the total minus my answer from above. So let's go to the graph and repeat the procedure. The value I get from the cumulative frequency scale is 38 plants. So this is the number less than 35 centimeters, 38 plants. So more than 35 centimeters is equal to 50 minus 38, and this will give me 12 plants. For question 13, I'll need to use the following formula for the gradient. So gradient is equal to 12 minus 48 over minus 5 minus 19. Put this on the calculator, the answer will come out to be minus 5 over 2. And then choose any point of those 2 points. I'll choose the first one, and using the equation of a straight line, which is y equals mx plus c, I'll start by using the gradient which I just found, so y equals minus 5 over 2x plus c. To find c, I'll use the point I mentioned above, so 12 equals minus 5 over 2 times minus 5 plus c. Solve for c, and you will find that this is equal to minus a half. Therefore, the equation of the straight line is y is equal to minus 5 over 2x minus a half. For question 14, I'll start by taking 2 as a common factor. This will give me 25g squared minus 9, and then this is the difference of 2 squares, which will give me 5g minus 3 and 5g plus 3, and that's the final answer. For question 15a, let's split this into 3 expressions. First, we've got the square root of 2, we've got the 8 to the power of 3, and then we have the 16 to the power of 3 over 2. So square root of 2 is just 2 to the power of 1 over 2. The 8 to the power of 3 is like saying 2 cubed for the 8 and then to the power of 3. This will give me 2 to the power of 9 because I multiply the powers. And then 16 to the power of 3 over 2. I will rewrite this as 2 to the 4 and then 3 to the power of 2. Again, multiply the powers. This will give me 2 to the power of 6. So let's go back to the original expression and start by changing the division to multiplication and flipping the fraction. So I get 16 to the power of 3 over 2 over 8 to the power of 3. Let's substitute what we found here. So 2 to the power of 1 over 2 times 2 to the power of 6 over 2 to the power of 9. I will subtract the powers. This will give me 2 to the power of 1 over 2 times 2 to the power of minus 3. And this simplifies to 2 to the minus 5 over 2, so n is minus 5 over 2. For part B, I need the 4% of that number, so 4 over 100 times that number. Now you can put this on the calculator, but some calculators cannot handle this because it's too big and they will give you an error. So to do this manually, start by considering this calculation. Now these you can do on the calculator, these are simple numbers, and this will give you 0.18 times 10 to the 157, and then I'm gonna multiply this number by 10, so I'll have to divide this number by 10 to keep a balance. So this will give me 1.8 times 10 to the 156, and that's the final answer. For part A of question 16, I have A union B consisting of 42 elements. So this region here consists of 42 elements, therefore 9 plus 5 plus x plus 3 plus 12 plus 7 is equal to 42. Solving for x will give you a value of 6. For part B, I want the number of elements in A dash. Now A dash is everything except this, therefore I will have 7 plus 10 plus 7 plus 12, which is equal to 36. And for part C, the number of elements in B dash intersection C, this is the region where C is without the region of B. So we take the whole of C and we remove the things that are included in B. So basically we only have 5 and 10. So 5 plus 10 will give me 15. For part A of question 17, consider the denominator of function g. Now the denominator of this fraction cannot be 0, so setting this equal to 0 will give me the value that I should exclude, and this is equal to 5 over 2. For part B, I'll start by first finding gh of x. Now gh of x implies that I'll take function g, and as an input I'm going to use function h, which is x squared plus 4. And to find this, I'll go at function g, and I will replace the x with x squared plus 4. So this will give me 11 over 2 bracket x squared plus 4, close the bracket, minus 5. Now let's simplify this. Expanding the denominator will give me 2x squared plus 8 minus 5. And if I simplify, I'll get 11 over 2x squared plus 3. Next step is to set this equal to 1. So 11 over 2x squared plus 3 is equal to 1. Let's cross multiply. 11 equals 2x squared plus 3 times 1, which gives me 2x squared plus 3. Take the 3 to the left, so 8 is equal to x squared. Divide by 2, 4 equals to x squared. Take the square root, x is equal to plus or minus the square root of 4, so plus or minus 2. But note that in the question I'm being told that x is greater than or equal to 0. So as my final answer, I have x equals to 2. Do not include the minus, otherwise you will not score full marks in this part. Usually I start the histogram questions by drawing 2 extra columns on my table, one for class width and one for frequency density. Now the class width is 5 for the first category, 10 for the second, 15 for the third, 10 for the fourth, and 20 for the last one. These are the difference between the upper bounds and the lower bounds of each category. Now to find the frequency density, I'll just divide frequency by class width. So I've got 4.6 for the first one. I can't find the second and third. I have 1.8 for the fourth category and 0.7 for the last category. Now the complexity of this question is that the two bars that I have on my histogram are the ones whose frequency densities are unknown and also frequencies, so I will handle this slightly different than other questions with histograms. I will use the fact that the frequency for those two categories combined is equal to 140, which is the total, minus the three frequencies that I have, which is 23, 18, and 14, and this will give me 85. And since I don't have a scale on my vertical axis, I will work with squares, and I've got 10 big squares here and 24 big squares here, so I have a total of 34 squares, and these 34 squares correspond to 85 people. Let's write this down. 34 squares is equal to 85 people. Hence 10 squares, which corresponds to this bar here, is equal to, and then just cross multiply 85 times 10 over 34 will give me 25 people. Thus the area of this bar here must be 25. The width is equal to 10, so the height of this bar must be 2.5, so that the area is 25. So now if I put a 2.5 here, this is enough to enable me to complete the vertical axis. Now that I have completed the scale on the vertical axis, I can read the height of this bar as well. So if I go to my table, the two missing frequency densities are 2.5 and 4, and if I multiply this and this, I will get the frequencies, which is 25 and 60. Finally, I can use the frequency densities of the first and last two categories to plot the missing bars. And that's how the complete histogram looks like. In question 19, I have this shape and I'm being told that M is the midpoint of OA. Therefore, if OM is equal to A, then MA is also equal to vector A. Also, ON to NB is 1 to 5. So if this is B, then NB must be equal to 5B. In part A, we need to find the vector AN. Now to go from A to N, this is equivalent to going from A to O and then from O to N. AO is twice the vector A in the reverse direction, so I get minus 2A plus the vector ON, which is equal to B, so minus 2A plus B is the required vector. Now for part B, I will have to split the line AN into two parts with some unknown ratio. Now I'm going to use fraction lambda for AP, so automatically Pn is 1 minus lambda. Lambda is a number between 0 and 1. Similarly, I have to split this line into an unknown ratio. MP to PB will be mu to 1 minus mu. And now the target is to find a starting and ending point through two different routes and then equate coefficients of vectors A and B. So let's choose, for example, AP. I'm going to do this twice. AP equals, so 1 root is the direct one going from here to here, and this is lambda times the vector AN. So lambda AN. Now we found AN in part A, so I've got lambda times minus 2A plus B. If I expand, I'll get minus 2 lambda A plus lambda B. Now I will find AP in a different way. So an alternative way is to go from A to M and then M times the vector MB. So let's write this down. I've got A to M plus MP. Now AM is minus A, MP is mu times MB. Now what is MB? Let's go back to the diagram. MB is equivalent to MO OB. So MO plus OB, therefore minus A plus mu. MO is minus A, and then OB is 6B. So I have an expression now in terms of A, B, and mu. Let's expand and simplify. Minus A minus mu A plus 6 mu B, and I'll factorize A from the first two. So I've got A here and minus 1 minus mu, and then plus 6 mu B. So for my next step, I will equate the coefficients of A. What I mean by that is the following. I've got minus 2 lambda A on the first approach. I've got minus 1 minus mu on the second one. So if I equate those two, I will get minus 2 lambda equals minus 1 minus mu, and then I will equate the coefficients of B. I've got lambda in the first one, 6 mu on the second one. So let's write this down. Lambda equals 6 mu. And now I will solve those two equations simultaneously. I will use substitution. I will substitute this lambda with 6 mu. So minus 2 bracket 6 mu equals minus 1 minus mu. Let's solve this. Minus 12 mu equals minus 1 minus mu. Let's rearrange, bring the minus 1 to the left, take the 12 to the right, so 11 mu. Therefore, 1 over 11 is equal to mu. Let's find lambda as well. I know that lambda equals 6 mu, therefore 6 over 11. Now, the ratio we want is AP to Pn. AP is lambda, Pn is 1 minus lambda. We found lambda to be 6 over 11, therefore 1 minus lambda is 5 over 11, and if I simplify this one, I'll get 6 to 5. For question 20, I will use two statements to create two equations and then solve them to find the first term and the common difference. The first equation will be created from the fact that the sum of the first 80 terms is equal to 470, and the second equation will be obtained from the fact that the 75th term is 14.5. So let's split the page into two and use the formula for the sum and for the nth term. So for the first equation, I have 80 over 2, 2a plus 80 minus 1d is equal to 470. So 40 is equal to A plus 79D equals 470. Divide both sides by 10 and then expand. 8A plus 316D equals to 47, and this is equation number 1. For the second equation, I have A plus 75 minus 1, D equals 14.5, so A plus 74D equals 14.5. This is equation number 2. So now I'm going to rewrite equation number 1, and then I'm going to take equation number 2, multiply it by 8, and get 8A plus 592D equals to 116. So now I can subtract the two equations, and the 8A will cancel out. This will give me minus 276D equals minus 69. So D comes out to be a quarter, or 0.25. Therefore, if I substitute now this value of D in any of the equations, I will find A. Let's do this with equation number 2. So A plus 74 times 0.25 equals 14.5. If you solve for A, you will get minus 4. Finally, I will use the fact that the sum of the first x terms is 171 and solve this to find x. Using the sum formula again, x over 2, 2 times the first term, plus x minus 1 times 0.25 equals to 171. Multiply both sides by 2 and then expand the square bracket. X minus 8 plus 0.25x minus 0.25 equals to 342. So x times minus 8.25 plus 0.25x equals 342. Expand the bracket, minus 8.25x plus 0.25x squared is equal to 342. Take everything to the left, 0.25x squared minus 8.25x minus 342 equals 0. Now you can use, if you want, the quadratic formula or simplify and then try and factorize. I will use the quadratic formula. Now this is given at the back of the cover on the formula sheet. For our case, A is 0.25, B is minus 8.25, and C is minus 342. So let's substitute the values in. So we get minus 8.25 plus or minus the square root of minus 8.25 squared. Be careful with the brackets. Minus 4 times A times C, and then all over 2A, so 2 times 0.25. Now put this on the calculator, ones with the plus, ones with the minus. One value will be 57, the other will be minus 24, which we will reject because x must be a positive integer, so 57 is our final answer. Question 21, it's quite straightforward and easy, given that it's 2 questions before the end. We've got 2 transformations and we need to find the image under those 2 transformations of the 0.65. Now the first transformation is f of x minus 4, and this is a translation by 4 units to the right. Hence, I will add 4 to the x-coordinate, it will become 10, and the y-coordinate will stay the same. And for part B, f of 3x, this is a stretch along the x-axis by a scale factor of 1 over 3. So this time I'm going to divide the x-coordinate by 3, so 6 divided by 3 is 2, and again the y-coordinate will stay the same. For question 22, let's define the following. Let uppercase r be the radius of the large circle and lowercase r be the radius of the smaller circle. Now the shaded area and the unshaded area, once added together, give you the area of the whole big circle. And since the shaded and unshaded areas are equal, it means that each one of those is equal to half the area of the large circle, hence a half pi r squared. Now let's divide our pentagon into 5 triangles. 2 of the sides of those triangles are equal to r, and the base is equal to 8. This is the side of the pentagon. And to find the angle at the top, I'm just going to do 360 divided by 5, which is equal to 72 degrees. So this is angle 72. Let's extract that triangle on the sides. Note that I have divided this triangle into 2 right angle triangles with a base of 4 and a hypotenuse of r. The angle at the top of each triangle is 72 divided by 2, which is 36. So now I can find the radius by doing trigonometry. So sine of 36 equals opposite over the hypotenuse, which is r. So r equals to 4 over sine of 36. If you want this as a decimal, this is 6.8 and so on. And now I'm going to find the area of this blue triangle. There are 2 ways. You can either use Pythagoras theorem to find the height and then do base times height over 2, or use the formula of the area of a triangle as given in the formula sheet, which is the following. And in our case, lowercase a and b are equal to r. So I have 1 over 2 times r times sine of angle C. In our case, C is the angle here, which is 72. So I've got 1 over 2 times 6.80 and so on squared times sine of 72. Put this on the calculator and you get the following answer. So the area of the pentagon is 5 triangles, so it's 5 times this value. Again, put this on the calculator and you will get the following. Next, I'm going to use the fact that the unshaded area, which is this one, is equal to the area of the pentagon minus the area of the small circle. So I'll get the following. Now the unshaded area, as mentioned above, is equal to a half pi r squared, same as the shaded one. So 1 over 2 pi r squared with an uppercase r equal to the area of the pentagon, which is 110.11 and so on, minus the small circle, which is pi r squared with a lowercase r. So 1 over 2 pi times 6.805 so on squared equals to 110.11 minus pi r squared. Rearrange to get pi r squared equals to 110.11 minus a half pi 6.805 squared. Put this on the calculator and you'll get the following answer. Divide by pi, so r squared is equal to the following. And finally take the square root, so r comes out to be 3.8 45 centimeters to three significant figures. First thing I'm going to do for question 23 is figure out the scale factor between the two pyramids. Since I know the heights of both pyramids, then 45, which is the height of the large one, divided by 15, which is the height of the small one, gives me 3, and that is my scale factor. Next, consider this triangle passes through the vertex of the pyramid, the large pyramid, and through the midpoints of two opposite sides of the pyramid. It also passes through the center of the base of the large pyramid. Let's extract this triangle. Now this is an isosceles triangle with a height of 45 and the base is 39, so half the base is 19.5, and I need to find the hypotenuse of one of those right angle triangles. So I get x squared is equal to 45 squared plus 19.5 squared. This will give me 2405.25. If I take the square root, I will get 49.04334817. And now what I'm going to do is I'm going to split these into two parts. Since the scale factor of the large pyramid relative to the small pyramid is 3, it means that A is a third of the whole distance of x, which means B is 2/3 of that distance. So B equals 2/3 of x. Therefore, B is equal to 32.69556545. Now, the reason I'm interested in B is because B is the height of this trapezium, and what is left for me to find the area of the trapezium is the top base, and note that this one is equal to the other sides of the square. So if I find this, which is equivalent to this distance here, then I'll find the top base of my trapezium. And again, coming here on this shape, if I label this distance as C, I know that the ratio of C to 39 is 1:3. Therefore, C is equal to 1/3 of 39, which is 13. Therefore, let me extract now the trapezium. I know the two bases, I know the height, the formula is given for the area, so let's plug in my numbers in. I've got 39 plus 13 times the height, which is 32.6 and so on, divided by 2, and this will give me 850.0847017. And finally, the total area of my shape is equal to the area of 4 trapezia plus the top square plus the bottom square. So let's plug in the numbers and find my answer. This is equal to 4 times 850 and so on, plus the top square, which is 13 times 13, plus the bottom one, 39 times 39. Put this on the calculator and you will get 5090.33 and so on. And the answer to the nearest whole number, so 5090 is my final answer.